Before I start my lecture, I would like to express my heartfelt thanks to Sri Lankan Heart Society members in general and Dr. Wazira sir in particular. And what I was supposed to speak on this session is about the guide wire selection. And as we all know, guide wire selection is the most important, and the success of PCI, the procedure depends entirely on the way you cross the lesion or not. That's how I think it's very apt to have good discussion about the guide wire selection. This slide brings best wishes from Apollo Group of Hospitals, where we presently head and try to network among the various hospitals and try to do some good work and collaborate and come out with some proper good academic research outcomes. I'm extremely thankful to my FACS professional service colleagues, where we hub and spoke model, we cover multiple hospitals. Especially in these tough times of COVID, it was a great help. And it's also very important to network with each other and to do high-end procedures. It goes a long way to have a group practice and team practice. And these are the various hospitals in which our team covers, and obviously the Apollo Health City being the main one, where the complex procedures get referred. Coming back to the topic, what we are supposed to discuss is regarding the guide wires. If you understand what is the guide wire purpose, obviously, you know the guide wire tracks through the vessel, accesses the lesion, crosses the lesion, but it is automatically. And by inadvertently, if you push and show your force, the entire vessel could get occluded. And obviously, later provide support for interventional devices, be it the balloon, stent, later, to take it on. So the small, thin 014 wire does wonders in these PCI procedures. So before we go on to the guide wire selection, if you have to understand little about how to select the wires, you need to know how the wires are made. So depending upon if you have that concept of the make of the wires, then you'll also know how to select these wires. So just for you to make it simple, each wire has a core, which is a central thing, and a cover, which gets covering and the coil at the tip, and the entire in the final tip will have again more of flexible nature. So the different designs happen depending upon the combinations of all this, and we will see how best the each desired properties come by various combinations of this. Just for you to remember, I made this mnemonic of A is coil, B is cover, C is sleeve of the wire. And then the major functions of the wire, if you see, the core is responsible for tactile feedback and how you feel about it, and it's a continuous force transmission from your end of the hand to the tip control. And then it is also, the tip is responsible for maneuvering and directing forces for tracking the wire. And that's why it's very important to properly shape the tip, which we'll discuss soon. The body is responsible for tracking, and the coating is important, especially for hydrophilicity and trackability of the wire. So that's how each of its components of the wire has a specific functions, and that's how all of us should understand this. And then the torqueability is basically when you are torquing or rotating here at the proximal end of the wire, what is it get happening at the tip of the wire? It's 1:1 tracking torqueability is happening. That means you get a good torqueable wire. Some of the senior cardiologists may excuse me because I thought it covering the various levels of people. I thought I would explain some basics too. Then trackability of wire is the ability of the wire to follow the wire tip around curves. Now you see tortuous vessels with elderly people be doing. Now we need to have good trackable wires to take the bends, avoid buckling, and navigate through the anatomy of vasculature so as to reach to the tip where you need to reach. And then the steerability is the ability of the guide wire tip to be delivered to the desired position of the vessel. If you have to go to distal position, sometimes you keep doing very distal RCAs and all that, you should be able to have a properly steerable wire. And obviously the flexibility of wire is important because if it's too stiff, then sometimes it becomes difficult to track on the devices. This is another better cartoon of the same wire make, showing the core and the inner and covers and the tip of the thing. And if you understand it, the distal tip may not have a coil so as to make it more shaping and more bend possibility. Then, as I said, if you have a stainless steel core material here, the probably support would be better. If it is nitinol, then probably it will be kink resistant. So that's how we have various types of wires which are done with a combination of it and then probably have different properties. Then the core diameter, if it is very thick in the center, obviously it will have better support. You don't need great brains to understand that. Whereas if the core is very thin inside, then probably that wire will be more flexible. But at the same time, the supporting nature could be less. So if you have a very tortuous calcific vessels where you need more support, probably we will take the help of a wire which has a strong core in the center. And what are they, we will briefly cover. And sometimes they also make, it's a great engineering marvel, I would say, the wire. Sometimes these wires, instead of being one, it is actually a 6-wire ropes which are done like this. That's why it is very important to have wires of a good make so as to not to have troubles. It might be a little easier to make balloon, nowadays stent also, but to make the wires with all these properties in a good form, it is again a challenging role. That's why not too many companies venture into it. Then if you see, this is also need to understand the tip of how it is tapering. This is the parabolic core here versus the tapered core here. Depending upon it, the bending stiffness characteristics vary with the wire. And one thing which is very important, apart from whatever the engineers make about the wires, there's no substitute for the feel of the wire, what you get at the end. That's what you get with the experience. So one wire, if you have to perform all, it's not possible always. That's why we have different types of wires. A word about the tip of the wire. As I said, the coil, it happens here. If you see the end, the tip, you may not have too much coil ribbon, or the central core may not extend here. So if the central core is not coming up to here, that tip will be very flexible. On the other hand, if the central core extends till here, probably it will be difficult to actually bend the wire at the tip. Many of you must be heard about the thing, gram tip load, how much it is. This cartoon shows it well. If you have to put the wire and the tip load tester at 10 mm from the tip of the wire, if you have to deflect this wire by 2 mm, how much pressure you need to apply here? That is what is basically 1 gram, 2 gram, 5 gram, 10 gram it applies. So you need to deflect this wire. That means if the wire is more stiffer, you need more stronger weight there to deflect the wire. That means it is more stiff. Whereas if it is less, then it is more flimsy and more soft. But if you also need to understand not only from the tip load, but if you have the penetration force and you sometimes take the help of microcatheters for supporting the wire, then the wire penetration force increases to 5 times. This is the concept we need to understand. The softer wires also tend to behave more like stiff. The other important nature of the wire is about coating, the lubricity. The hydrophilic nature of the wire, when it gets in contact with water or blood, then it becomes more activated and becomes slippery. Whereas the hydrophobic nature repels water and they don't need. So some of these wires like Whisper, other things which have good coating, or once it gets into the body, it becomes more slippery. But it's also important for us to understand the lubricity versus tactile feedback are inversely correlated. If you have a good hydrophilic coating wire, it's very lubricant, slips through, but the tactile feedback may not be the same. You may not appreciate the resistance which is coming from the tip of the wire to in your hand. Whereas if it's hydrophilic coating or no coating, then the feedback of tactile feedback would be better. So these are some concepts which I wanted to throw before we go on. And the other basic principles of the wire, apart from knowing the wire anatomy and structure, is don't keep on using various types of wires. We need to become comfortable. Each of you first limit the number of wires which you're using, though we need to have comfortableness in 3-4 types of wires, at least depending upon the coronary anatomy. But for each of it, you need not have too many types of it. That's what I mentioned here. Limit the number of wires you're using. Use wires with vastly different properties. When we mean change of a wire, that means the soft wire is not crossing. You have to go to stiff wire, change it totally. Like you started with cross it 50, there's no point going to 100, 200 like that in the same. You go to more powerful, more strength wire. Then if one wire strategy is not working, then switch immediately. So initially, many of the times faint track is there with the filter XT type of wires. It doesn't cross, then switch over to stiffer wires. There's no point again trying another type of filter wire there itself. That's the concept we need to understand. But we need to also have once the specialty wire has achieved its mission, you can change to a safer wire with the microcatheter exchange, whichever you use a workhorse wire. The regular workhorse wires is what we use, and the frontline finesse sometimes is required, sometimes extra support is required. Specialty wires are CTO wires, which I'll touch upon briefly. This is again some of the tips and tricks for the wires. Use a regular workhorse wires. What we use in our lab is a run-through wire, which is from Turbo, which is I feel is a major advancements. Previously also used to use All-Star and BMW wires, which are used as workhorse bypass wires in many of the labs. Preferably when you are accessing side branches, always have a bigger curve at the end. Where it is very critical narrowing, the tip of the curve should be very smaller there. The same is the case with CTO wires. Then always wire both branches in case of bifurcation to avoid branch occlusions, avoid wire entanglements. New generations like Fielder XT, which have a 0.09 inch slippery coating, very useful in a significant number of CTO patients because where is a strain track which takes this, and later on the tortuosities also are gone better. But at the same time, a whisper type of wire, you need to have a better support. The whisper extra support wires have come. But especially in types of tortuous anatomies, calcifications, where you need extra support to deliver the material, you need to either have a body wire technique or take Iron Man or Grand Slam type of wires. And the CTO wires are basically Gaia series and CrossFit series of wires. Handle them carefully, and you should use them after reasonable experience. So these are the various types of CTO specialty wires. For sake of time, I can't go into details of it. What I would mention is probably Confluencia or Conquest Pro, all those types of wires which are very stiff are to be used with extremely caution. Beginners can start with Gaia type of wires and gradually go into more wires which are comfortable. So depending upon what type of anatomy which you're facing, what is the lesion morphology and what are the devices to be used, we select the wires. Now, obviously the most important is the operator's experience and your preference. And the workhorse wires I've mentioned basically as BMW wires, or like many of the centers now we have run through as a workhorse wires. More finer wires, probably whisper wires, and then extra support wire is Iron Man and Grand Slam wire, and specialty wires are CrossFit, Shinobi, and the Gaia type of wires which are there. And then what is more important is shaping the tip appropriately and maintaining a free movement of the wire. If wire is getting stuck, it's not a place to show your pressure and the strength there. So you come back, make it free, then torque it, and again go. Now withdraw the deposition of the wire if it is needed. That's what I was mentioning. Avoid undue force. It's not a place to show your strength. It's not a battleground there. Avoid excessive rotation. Whatever you're turning, it should be communicated there distally. So sometimes these wires will also help us to stabilize the guides. Yeah, that is another point which I briefly wanted to mention. Is tortuous vessels. If it is there, probably putting another wire will help us to avoid that. And sometimes it also helps in anchoring this with anchoring balloon technique or placing another wire. I call it actually stirrup technique, where you have two wires, you're holding it, then there will be great strength to track the devices on the wires. That's important. Not only stabilization of guide, but they make it like more like a solid rods on which you can take this again balloons or stents later. Though we also take the help of guideliners nowadays in today's. So that's what I would like to mention in the given allotted time is basically you should be very specific and become comfortable with the type of wires what you have. And each of the type of wires, maybe if you have a workhorse wire, as I mentioned, a run-through wire, or probably BMW or All-Star wire are okay. If you need to go a little more like slippery wires, then probably coated wires like Whisper and probably Fielder XT are fine. But at the same time, you should also understand that slippery wires tend to slip and produce wire perforations distally, and then you need to have a proper control. That's why once the job is done, you exchange it to your regular workhorse wire. Whereas if you're dealing with a situation where there is more of angulations, tortuosity, calcification, you need better support strength. You need wires which have a stronger core inside. That is what we use as Iron Man and Grand Slam type of wires which we use. And the CTO wires, generally, most of the CTOs could be crossed with Fielder XT because of faint channel, if it is there. Otherwise, when you switch over, probably we use Gaia series, but if you're comfortable using Pilot series, whatever, you become comfortable with it. And when you're switching over, because of a stiffness or some other problem you're encountering, switch over to a different make altogether rather than switching in the same type of wires. That is the importance of the guide wire selection depending on specific lesions. But what I would again recommend is you become comfortable with few wires and keep using them. At least a half a dozen of them, you can have it on shelf. But basic properties of the wires and the technical background of guide wires which make, you need to be comfortable. So that's how I say that you need to have various different types of wires available, and probably to tackle the various types of scenarios. That's how you need to conquer these PCI lesions in most of the scenarios, be it like a tortuosity or calcifications or a CTO type of lesions. Thank you all, and I thank Dr. Wazira and other members from Sri Lankan Art Society who made this recent TCT meeting. We now actually, Sri Lanka is a part of our meeting, TCT India South Asia. It is attended by 5,500 plus people, and all these our lectures, and some of them delivered by our Sri Lankan friends, is also available on the website. Please go through this video on demand format. Thank you once again for patient hearing. Thank you.
Thank you, Dr. Srinivas Kumar, for a very comprehensive and excellent lecture. Now we have come to the end of this symposium. It is open for discussion now. If there are any questions, you can ask now.
Thank you, Dr. Srinivas, once again. While we are waiting for the questions to come in, I will ask you a question. Now, in bifurcation lesions, or when we want to preserve the side branch and we want to wire it, are there any wires that you prefer, and are there any ways of putting the bend on the wire? Is there anything that you would like to tell us about that?
A slightly bigger bend at the tip of the wire, and also if you have some specialty wires which have a bigger bend, like Abbott has a special wire which goes with a bigger bend there. So such sort of things you can use, but basically whichever wires you're comfortable with, depending upon the angulation of the branch, I think you need to pre-shape the wire slightly, and you try to go into the distal vessel, and while coming back, it tends to fill. That way it helps to post-stenting. If you're trying to do it, helps to go through a distal strut of the stent.
And